So I was only standing there hovering because I was trying to make the software work on my end, so fear not. All right, I'm going to close the big code. If you've not yet joined, it's going to be up there in the top right. And we need to jump all the way down here, and you do not need to answer this again in the Pear Deck. You guys did that yesterday, and Christian and Casey are the two people who have broken almost a 3-year losing streak on this. I mean, don't feel bad if you didn't answer it correctly. It was meant to be difficult. Casey and Christian, right, operationalized religiosity. Well, let's talk about conceptualization. As a concept, religiosity means how strongly one feels about their religion, how committed they are to their religion. Yes, Allison.
I feel a little nauseous.
Okay, yep, go ahead and step out. That's.
You know where the nurse's office is at or something?
I
know where it is.
If somebody wants to walk with her. See, Olivia, I'll have you do it that way. We don't have, we've got people at both ends of the room. Okay. So that's the definition. Operationalizing means how are we going to measure this? Now, a lot of answers that I've gotten over times that I've used this have said, well, like ask people what their religion is, ask them how strongly they feel about it, how important it is in their life, and you can do those things. But there's a problem. And that may seem unfair because I just had previously told you that if you want to operationalize race, you should operationalize it as whatever people say their race is. Right? That's how you measure it. In this case, though, that won't work. And here's why. We imagine that, let's see. Let's imagine that Sam, right? He's a pollster. And I've hired him because I've got this sociological question about religiosity. And I've hired Sam to call people up and ask them about it. And Sam calls up Kevin. Right? And says to Kevin, Kevin, on a scale of 1 to 7, how religious are you? Now, Kevin, this is all made up, by the way. This is not something I've asked Kevin about. Prior to being asked that question by Sam, it's quite possible that Kevin hasn't thought about religion in years. Or at least his own religion in years. But if we jump back to when Kevin was a child, Kevin went to Catholic school. No, scratch that, not a Catholic school. Kevin went to a private school that was run by evangelical Christians. He attended church 3 times a week, Wednesdays, Saturday, and Sunday, with a very devout grandmother. And Kevin had often been taught in his life that his personal belief that Jesus was his Savior was what guaranteed his salvation. And that it was very important to participate, right, in your congregation, right, and share that religion with other people. And now, because Sam has asked him one question, that all comes flooding back to Kevin. Kevin, right, without thinking about those things, might have just said 1. Right? Definitely 1 out of 7. Right? If you had a 0, I'd pick 0. Right? Not religious at all. But now, right, Kevin's got some doubts. Right? He's saying, oh, shoot. And is my soul safe? What's going to happen to me when I die? And now Kevin doesn't want to say the wrong thing. Right? And so Kevin says it's a 5. Right? He doesn't want to be over the top. He doesn't want to say a 7. He's going to think Sam's not going to believe a 7. But I'll go with a 5. And this is the problem. Right? When you ask somebody a question like that, it's quite likely that they will answer that they are more religious than they actually are. So what do we do instead? Well, we do what Christian and Casey suggested. We ask them how often they attend worship services. I think you guys the question was, how often do you go to church, right? And that can work, but expand that out to include people who would go to a temple or a synagogue or a mosque. And we just ask people how often they attend worship services. Because if we ask Kevin that, Kevin probably doesn't have a lot of those other thoughts. He's just like, man, I haven't gone in a long time, 0 times a year. Right? And gives us a much more honest and accurate measure. Yes, Emma.
That was actually also one of my ideas.
Okay.
Yeah.
I didn't scan through the whole list. I was like, I think
I didn't put that exactly.
Okay.
But that's kind of what I meant when I did.
Yeah. No, and that's
Don't ask them just directly like how religious are you, but ask them questions that can lead you to that conclusion.
yeah, that get at that. No, you were definitely also then on the right track. You've got to ask what's called kind of a proxy. Right? Because if you ask the direct question, you'll get inaccurate answers. The next step is to state your hypothesis. Students have a lot of trouble with this step, at least in my classroom, and that's because I'm a weirdo. But I'm not really a weird, not for that reason. I'm sure I'm a weirdo for lots of other reasons, but not for this one. But I need you to stop thinking about hypotheses the way everyone else in your life has always told you to think about them. From the time you were elementary school students, people told you that a hypothesis is an educated guess. You probably have teachers in this school building that tell you that a hypothesis is an educated guess. But it's not. Now, if you have other classes with teachers who say that, just smile and nod your head and go along with it. They ask you on a test, what is a hypothesis? Right now, it's an educated guess. It's fine. I'm not telling you to rock the boat, but it's not an educated guess. By the time we've gotten to step 5, we know exactly what to expect. We've read about other theories. We've thought hard about our variables, how we're going to define them, how we're going to measure them. We're not guessing at all. Our theory tells us what we should expect. We're not guessing. Yes, Val.
What's the code?
It is. I don't know why it keeps covering it up. Okay, it is UBK JJH.
I populated Missouri on all of them.
That's all right. Just erase it as you go. It doesn't look like it did it to other pages. But in my class, at least, right?
Missouri,
It's all right. It'll be okay. You'll be able to erase those and type over it. Make sure when I ask you whether if a hypothesis is an educated guess that you will always answer no. It is, if Pear Deck will cooperate, seems unlikely today, it's the relationship you expect to see between your variables. And we call that relationship correlation, and how they are correlated, and how they change together. So often our variables are described as x and y. X is our independent variable, y is our dependent variable. You do need to be careful as you state a hypothesis. The classic formulation of a hypothesis is the if-then statement. If this happens, then that happens. That might work in some sciences. Social sciences are messy, so we should use alternatives. We should use the probabilistic hypothesis. And I know some of you just heard ballistic and you think this is going to be exciting. It's not. Right? I don't mean ballistics as in bullets and trajectories and terminal velocities and damage. I mean probability. Right? That's that math class stuff that's much less exciting. Right? But probability. The more X, the more likely Y. Because the social world is messy. We don't really get to make strong if-then statements. And if you do insist on making an if-then statement, we punish you by requiring you to use Latin. All right, and I know some of you were already at least half dead looking at this screen thinking, oh, hypothesis, did it get worse? Yes, I just added some Latin to the mix. All right.
Oh, God.
Ceteris paribus means all other things being equal. And we need to add that because if we're going to make an if-then statement, we need to be very clear that that's assuming everything else is the same. Because I'm to say, Porter, congratulations, you're a billionaire. You might not have known it until now, but I've just received word, and this is not a scam coming out of Pakistan this time, right? This is for real. Your Amazon account is not locked. Netflix is fine, but right, you have received $2 billion and you're a billionaire. Congratulations. Then Liz calls you up. Liz is an oncologist. Right? Those are the cancer doctors. This is not going to be good. All right, Porter, right, you've got a terminal kind of cancer. It's metastasized everywhere. You've got maybe a month to live. It's going to be horribly painful the whole time. Porter, were you happy for a minute when you found out you had a couple $1 billion? Did that make you? Yes. But what happened immediately when Liz told you about your cancer diagnosis? Did you stop being happy? Yeah, you stopped being happy. Right? You're very rich. You don't have any time to spend it, and you're going to be in horrible pain the whole time. That's why we need all other things being equal. Right? Because if we have two people with $2 billion, but one of them is healthy and one of them is dying and in horrible pain, they're probably not going to be equally happy.
Yeah, that's just common sense, I think. Some of it.
Can be, but it means that we need to be careful when we state a hypothesis. So here are some examples that are built on our theories. The wealthier a person is, the more likely they are to be happy. If we want to be extra careful, we can still add that all other things being equal. I thought I fixed that on the slide. It is at least fixed in your notes. Yes, it is okay in your notes, right? The more ethnically homogenous a place is, the happier its people will be. The more the government spends on public services, the happier people will be. Here's close to an if-then statement. We don't always have to use the then. If people are trusting, they will be happy. Now, this is not a Pear Deck question, but can anybody tell me why these are different than the theories that we talked about? They look a lot alike. They sound a lot alike, but they're missing something. What are they missing that our theories had? Close. Emma. Oh, you can add a then there. I don't know why things are missing from my slide, but yeah, you can add a then right before they will be happy. Don't know what's going on there. Anybody else got an idea of what's missing, Porter?
Is it a question?
Yeah, well, not a question. You're so close. You've just got like the flip side of it.
An answer.
An answer, right? The explanation is what's missing. Right? The theory explains the connection between wealth and happiness, homogeneity and happiness, government spending and happiness, trust and happiness. A hypothesis does not provide that explanation. You don't need to. Again, you've already told people what your theory is. In a hypothesis, you are stripping it down to as simple a statement as you can make. This is the relationship I expect to see between my dependent variable wealth and my independent variable happiness. It's simply a statement of what you expect to see in the evidence.
So, on C prior what's another line?
All other things being equal. I really don't know what's going on. Yeah, all other things being equal. Yeah, I mean, it's especially weird because I made your notes slides after I made this presentation, so there shouldn't be anything missing from that is in your notes, but it is. All right, so step 6. Now we've stated our hypothesis. Now we need to test it. This is going to be a bit of review. We've got different forms of evidence to test our hypothesis, but remember, we do need evidence. Logic and arguments aren't good enough. We need good empirical, real-world evidence. That could be quantitative. Quantitative means things that are numerical. It could be statistical methods. Is there anybody in here taking or have taken a stats class here? Okay. You in it right now? You don't look happy about that. I'm not going to say names. Don't worry. This is being recorded. Okay. So I will tell statistics is rough. And there was another student in 4th hour taking it. You guys are doing lots of stuff, making calculations yourselves, using graphing calculators. Like, that's not the fun statistics. It's not your teacher's fault that it's not the fun statistics. But I will tell you, this is why I'm asking, if you're taking a stats class and you hate it, just hang in there. Don't give up on anything that involves statistics. There are software packages that will do all of that math and make it happen in a black box. You don't have to look inside. Right? You could just trust the software, and then you can do really cool things and answer really interesting questions and make pretty graphs that are easy for people to understand so that they don't have to do the statistics you've suffered through. It's good, but it's hard. For those of you who will never be persuaded to do things with numbers, and that's okay. I know lots of people who don't want to do things with numbers or have questions that numbers can't answer. You can use qualitative evidence, which is non-numerical. It involves you doing a very detailed comparison of things, or maybe doing some research about history, especially to trace the process of something. The example we used before is you can't understand the difference in attitudes towards homosexuality or same-sex marriage in the 1950s versus 2023. You can't just compare those two time periods all by themselves. You have to look at the process that changed those attitudes over time. Whichever method you use, you're still dealing with correlation, which is how the variables change together. As we talk about correlation, there are kind of 4 things that are important ways to describe a correlation. 1, we need to know the direction. If it's a positive correlation, then the 2 variables change in the same direction. As one goes up, the other goes up. Right? As Porter's wealth went up, Porter's happiness went up. That's positive. Negative means things change in different directions. Right? As Porter's pain goes up, his happiness goes down. We also need to know how strong the correlation is. And a strong correlation simply means that a change in one variable closely matches a change in the other variable. If it's weak, on the other hand, the data's all over the place. A change in one variable doesn't seem to be clearly related, if at all related, to a change in the other variable. one of the sayings you may have heard in some of your other classes, and this one I have no trouble with at all, is that correlation is not causation, because it really isn't, and you need to be really careful with the conclusions you draw from a correlation. The classic example of this that everybody uses, I don't know who originally did it, but we've all stolen it ever since, is as ice cream sales go up, homicide rates go up. So there is a positive correlation between how much ice cream people are buying and how many people are being murdered.
That's not a positive correlation.
Well, no, it would be. Ice cream sales go up, murders go up. Right? They go together, and it's not super strong, but it's reasonably strong. So do ice cream sales cause murder?
No.
No.
Also, like something that people do like this, just because like something is called a positive change doesn't always mean that it's a good thing.
Right. Yeah, I run into that in this class with positive theory, because it just means objective and fact-based, and positive correlation in law and citizen. I run into it with positive rights and negative rights. Whenever I tell somebody that the Second Amendment with its right to bear arms is a negative right, somebody gets angry like Dr. Brown hates guns. No, it's a negative right because they leave you alone. So that is one of the things that happens. And you're absolutely right. So none of you seem to believe that ice cream causes murder. So let's think about some other things that could be going on. When does most ice cream get bought by people?
In the summer, because it's nice and warm, it's something to cool off with.
Okay, and I've never understood. I mean, maybe when I was a kid, but now as an oldster, when I eat like a frozen dairy product and then go stand outside in the hot sun, it just makes me feel miserable. But I enjoy being young while it lasts. But yes, people buy ice cream when it's summertime and then when it's hot outside. Okay. So you've already also given me another thing that is an important detail. Right? People are outside with other people.
Yes.
Right? If you're at home alone, you can't murder anybody. You can
Not
suicide.
with that attitude.
Not with that attitude. Look at Dr. Brown telling us what we can't do.
I mean, if you have a hostage, technically.
I suppose. But if you're home all alone, no hostages, no nothing, you can't murder anybody. But if you're out and about and there are other people around, you can murder them.
Yes.
Okay. So, one, we've got the possibility. You're around more people. The more people you're around, the more people you could possibly murder, or the more people could possibly murder you. Okay, so that helps. Help us understand what's going on. What are people like in terms of their attitude when it's really hot outside?
Irritable.
Irritable, right? They're hot, they're sweaty, they're irritable, their tempers are short. So you're around other people and you're irritable. Okay. That's probably what makes you more likely to kill people, right? Or to be killed by somebody else. It's not the ice cream. But if we just went based on correlation, we would think ice cream causes people to murder people.
I don't know. I've seen people fight over a bag of Doritos, man. This is America.
Well, this is America. That's true. We've all seen those videos of Black Friday with people killing each other to get a Tickle Me Elmo, which
You said it wrong. It's America.
America. Yeah, sorry.
America.
It's all right. I should know better. I was just the other day listening to the Team America soundtrack with a song that includes such gems as "Freedom Costs a $1.05," and some other things that I can't say in class. All right. So correlation is not causation, but it is evidence. And if we have a strong theory that tells us why we expect to see this correlation, then it is evidence we can use. But you need the theory first. All right, we're going to work through some examples together. We're not going to finish today, but we're going to get a good start. I'm going to jump us a little bit ahead. This is after we've done a literature review. Let's say our question is, why are some people taller and other people are shorter? And we've looked through the literature and we think we've got a pretty good answer. It's genetics. Different genes are responsible for people having different heights. And people inherit their genes from their parents. So, parents and their children should have heights that are similar when they're adults. So that tells us our relationship, or our variables, and explains the connection between them. The hypothesis, again, is just the statement of the relationship we expect to see. It doesn't tell us why. It doesn't mention genetics at all. It's not supposed to. It's just supposed to tell us what we should see in the evidence. And so the taller a father is, the taller his son will be, all other things being equal. For the Pear Deck, don't shout this out, but why do we need to add some Latin, or all other things being equal, to the end of that hypothesis? Don't be afraid to give a wrong answer. Also be aware there are multiple answers that are correct. Why do we need to hedge our bets and add all other things being equal to that hypothesis? Oh, it's just the one up there. Why do we need to add all other things being equal to that hypothesis? Add a little bit of time to that clock. Okay, that's okay. That's all right. If I can get Pear Deck to show us, though, which I can't. All right. Well, from what you guys answered, said that genetics isn't everything, and it's not necessarily. If you go back, about 100, 150 years ago in Finland, there were lots of people running around in Finland who had the genes to be really tall. Unfortunately, they lived in a place with very little sunlight and poor nutrition, so a lot of those kids ended up with rickets, which means your bones are too soft, you end up bow-legged, things don't grow right, and so you're not as tall as you could be. So that's part of it. Some of you also pointed out that leaves out one of the parents. So it could be that the father is tall, but the mother is short. And that's a pretty common thing to happen. And believe it or not, one point in time, the men in my family were like 6 feet tall. My great-grandfather was 6 feet tall, but he married a woman who was at her tallest probably 4'10", 4'11". And from then on, you get little hobbit people like me running around. Right? And then my grandpa married a woman that was the same height as him, but he was only 5'7". His daughter was about 5'7". My dad's about 5'7", and there we go, right? So it matters. My father-in-law, 6'4", married a woman who's about 5'2", son's 6 foot tall, right? So not short, but shorter. Yes. Emma.
There's also sometimes those kind of conditions that can affect height that
Yeah.
necessarily genetically pass down.
Right.
Like you can get from something that happens
Yeah.
in your life, or that say the father might not have, but the son does.
Right.
Or the father has it.
Yeah, because that happens. My neighbor is he's a little bit taller than I am, which isn't saying much, but his son is like 6'7". Right? So things happen, right, that don't always follow. But yes, that's why we need to add all other things being equal. Well, let's just skip the pair deck on that one because it's already told us. The dependent variable is the son's height, and the independent variable is the father's height, right? Because we don't think that a tall son causes a tall father. That would be weird. The dependent variable is the son's height. The independent variable is the father's height.
Why did you say it makes sense? That's what.
Oh, that a tall son would cause a tall father. Like my son is on track to be like pretty significantly taller than me, but that's not going to make me any taller.
No, you're not going to start growing.
No, I mean I'm set. I'm stuck. I'm actually only going to shrink. That seems to be the other part of my family's legacy. That we've kind of gotten some of our steps in a strange order, but I think it's easier to work through it this way. We're going to conceptualize a few variables in this slide with this pair deck. The first one, probably the only one we'll get through today, is what is height? Conceptualize it. What is height? Define height in the pair deck. Don't say anything out loud.
Trick question.
It kind of works out that way. It's not meant to be.
Because I think I did literal.
No, literal is fine. It's, I suppose, tricky in a different way. Let's see if we have any better luck with letting us see. Nope, it's not going to. Well, let me try that. Okay, will if I do it there. All right, now I've flagged one of these. Okay, so this is what makes it a trick question. So it is how tall someone is. But this is where I want you to be careful. It's not like this is a world-ending thing, but think about conceptualization and operationalization as two very different steps. All right. The concept is height is how tall someone is. And lots of you guys had answers like that, right? The distance from a person's, the bottom of their feet to the top of their head. When you add in the feet or inches or centimeters, you're telling me how you're going to measure it, which all that means is you've gotten ahead of yourself and gone on to the next step. All right, we'll continue with this tomorrow. All right, for now, just make sure your notes are saved. All right, you may get up and pack up for lunch. What's that?
I was gonna try and over-explain it.
Yeah, well, and like I said, that's why when Sean asked if it's a trick question, I said it tends to work out that